Welcome to the second part of integration of last lesson class about microcontroller and logic. So how to practice the concept we saw last time. Here we have another platform, another web application. Instead of Microbit, we can use this application called Tinkercad. You will be familiar with Tinkercad because next week you will also use it for 3D modeling. 3D modeling is necessary in order to start using the 3D printer. So actually this application is very useful because it has both. You can either use it for 3D modeling here. So if you click on 3D, you can see some of my models I create for personal user, either personal use and for clients. And if I click on circuit, you can see some of the circuit I simulated. So to create a new one, just click on create circuit, and the interface will open in few moments here. So here on the right you have the menu with all the components you need. In our case, we want to practice the Arduino. We can also use the Microbit, but we are not interested in it right now, so I can just click, drag and drop an Arduino here. Perfect, this is it. I want to practice a specific program we did last time, and is the one with the servo. So how to connect a servo with it, with the Arduino. I start searching for the servo. So on the search bar I type servo here, and here we are. We have two options. I choose the first one. Here's the servo. This is it. Drag and drop. We have the two components necessary for the program we want to simulate. So servo. Last time I emphasized the connection between servo and microbit. Told you there were three cables from the servo. Two were for powering up the servo, so alimentation of the servo, and one was for the data, so the communication between Arduino and servo. Here it's the same because we have three pins. One is the ground, the negative of the alimentation, power, the positive, signal, the data. That's it. How to connect the servo to the Arduino. If we zoom in with the Arduino, we can see a row of pins here and another row below, but they are all labeled. So how to power up the servo with the Arduino? Well, I will say using the power pin here, and we can see we have 3.3 volt as microbit, ground, two pins of ground as the microbit. Well, microbit just had one. I think in our case we have two, and we also have a third one here above. What else? 5 volt. So another different voltage for powering up different components. In our case, we want to power up the servo with 5 volt. Although with microbit we use the 3.3. Actually it's the same, just like give different power to the servo. But let's use 5 volt because with Arduino we're going to use multiple components and actuator connected, like powered up just with 5 volt. So how to do that? Start with the ground. I click on here. A cable start coming up from the pin, so I want to connect ground with ground. This is it. What is the convention, the color convention of the ground? It's black. The negative of the battery of, in this case, the alimentation, is always black. So I change the color to black. Power, it's the same. Start here. I define the path of the cable, and here we go. We connect to 5 volt. What is the convention of the color? It's red. Does the color change something about the hardware or the code? No, nothing. It's just a convention to be, to simplify the view of the schematic. Data. I connect to the pin 9 here. like this. Color doesn't matter. I will choose green. Okay. So about the connection of the data, I need to use a digital pin. Okay. From 2 to 13 are pin like allowed to be used for this connection. 0 and 1 also can be used, but you need to be more careful about this pin because TX and RX, the label you will find in 0 and 1 pin, refer to transmission and receiving. So those pins are also used for communication between Arduinos, if you want to connect more of them, and we will need to use them for the final project because I want to remind you that we're going to connect more kits in order to have a bigger robot, and also are used for the connection between Arduino and the computer. If you want to send data, you want to analyze or you want to check, so you need this communication to be free. So you don't want to connect components here eventually to avoid conflicts. This is it about the connection. So what about the code? If you see here on the top of the menu, you will find the code editor button. So if you click on it, you can see we have the same typology of coding structure we have seen on microbit, so blocking typology. Here we also have the option to have both blocks and text. So if we click on it, we have this kind of interface. It's very useful if you are still very comfortable on the microbit type of code and you want to see how the programming language, the Arduino programming language works. So in this case, for example, if I modify the blocks, I cannot edit the text. I can just operate on the block side. So for example, like adding this servo instruction, you will see the code, the text code will be automatically translated. But here I will demonstrate, I will show you how to work directly on text, because at the end we are gonna work directly with the Arduino language code. So let's switch on pure text and we have it. So I want to replicate the gradual moving of the servo, so that exercise we saw last lesson. I already have everything prepared here. So this is the connection, this is the code. Okay, so this is basically almost the same code I showed you and that you will find also in the slide that I will upload after I finish editing and recording these videos, hopefully, because today is Sunday, as you can see, as you can tell from my sleeveless outfit, and we will see how much time do I have for doing this, but eventually, or tonight, Sunday, or tomorrow morning, Monday morning. So I was saying almost the same program. What was the difference? In the slide, you can see that the range of operation of the servo was from 170 to 10, and here the second 4, it was from 10 to 170. Why so? Why I did a smaller range? Honestly, I don't remember, but actually this doesn't make any difference because the logic is the same. We just can choose how large the servo can operate, so we can choose the range. The logic is the same. I just changed the number from 180 to 0, 0, 180. The logic is the same. You can see also there is a new kind of instruction here. This one, serial dot begin 9600, and here serial print and serial print. What do they do? Just displaying the numbers on the serial monitor. The Arduino, when it's connected to the computer, can also give to the computer the numbers we want to, I don't know, see because of debugging reason, for example. In this case, I wanted to see, okay, whenever you are in the 4 structure, so whenever you are changing, every time you are changing the angle of the servo with this instruction, I also want to see the number of the variable pos, the position of the servo, displayed on the serial monitor. You will find the serial monitor identically on the Arduino IDE, not just on the simulator. So, just to give you the simulation, I can start the simulation, and here we are. So as you can see, the servo is moving from 0 to 180 degree, and the number are changing consequentially. Those are the angles the servo is moving from and to. If it's a little bit slow, it's because I'm recording and simulating at the same time, so it's a laptop laptop problem here. But this is it. So this is the simulations I want to show you. I suggest you to copy and test all the Arduino program I showed you in the last class. There are like 3, maybe maximum 4, but I suppose 3 there are. So about the LED, about the buttons, and you also have the schematics of the buttons, and here this one about the servo. If you want to try more things, you're very welcome. On the internet you will find so many things to play with. So this is it about introduction of Tinkercad and Circuit Simulator. See you next week.